So what I want to do now before we move on to regression is look at and compare various tests that we've learned about so far, because some of them are easily confused. And so I want to hopefully clear up some of that confusion by highlighting their similarities and differences. So one of the first confusions is that a lot of people confuse correlation with dependent t-tests, right? And so what you need to understand here is that when you are using correlation, you're looking for a relationship between the scores, right? So you have two variables, and you want to know if those two variables, x and y, are correlated. Right? So when scores change on X, what happens to the scores on Y? If scores on Y change in a predictable way with changes in X, then you can say that there is a relationship there between these two variables. But this is not the same thing as looking for a difference between the means, right? You can have two groups and you calculate the mean for group 1 and the mean for group 2, and you want to know, are those two means different from each other? You're asking an entirely different question here. This first question is about relationship among scores, and the second is looking for differences among or between means. So correlation is the statistic that is going to look at the relationship among scores. And dependent t-tests are, T for 2, going to look at differences between two means. But remember, if it's a dependent t-test, it means that either the people in group 1 are the same set of people as in group 2, or they've been paired. All right? Now, why is it that correlation is confused with dependent t-tests? Well, there's a couple of reasons here. First of all, I don't know if you've noticed, but when you're looking at the output for a dependent t-test on, SPSS, there is a box in the output section that says, I think it says correlation. So they actually have a correlation as part of the output for the dependent t-test. And so that is one reason why you might confuse correlation with dependent t-test. And in fact, I believe I told you when you're doing that dependent t-test, ignore that box. That's not what we're interested in. When we run that dependent t-test, we want to know if the two means are different. But another important reason I think why people confuse correlation with dependent t-tests is because remember, the assumption of correlation is that you are looking at related pairs, which means the scores, for X and the score for Y come from the same person or the same day or whatever, okay? So if I'm correlating, study time and final grade, and you are a participant in my study, then I'm going to ask at how long did you study, and I'm going to match that up with your grade, right? It would make no sense for me to ask how much did you study and then match that score up with somebody else's grade, all right? So you see how correlation, the numbers line up, right? So participant 1 on X lines up with participant 1 on Y. So it's kind of the same thing with a dependent t-test. If you have two groups, whoever's, let's say subject or participant number 1, in condition 1, you have to line their score up with, how they scored in condition number 2. All right, because it's the same people tested twice, so you match up or line up their scores. So you can see where the confusion lies, right? Okay. So just to reinforce the idea here that when we ask about relationships, we are asking a very different question than, asking about whether means are different. And this is why I was really, really adamant when you were learning about t-tests and ANOVAs, which are all about means. I gave you that forbidden word. I really wanted you to understand that when we are comparing means, we are not looking at relationships. All right? That's why I did that. Okay, so let's look at this first example. Now here we have x and y. So this could be variable x, variable y, right? If we're doing correlation. If we're looking at a t-test, this will be, level 1 of the independent variable and level 2 of the independent variable. So, these are just the two categories of our IV. Okay, if we were to plot the scores of x and y, so ignore the means here. We're just going to plot these values. This is what we would get, right? Now, you should all recognize that, the best fitting line here would go right through all the dots. And it's a positive slope. So this R value would be +1, a perfect positive relationship. As scores on X increase, so do scores on Y, and it's perfectly predictable. There's no dots off the line, so there's no error, in that relationship. So certainly, if we were to test to see if R is significant, we would find that, yes, R is significant. Now, what if we were to treat these, instead of scores on variable X and scores on a second variable Y, what if we were to treat these as level 1, level 2 of our independent variable? So this is the mean for level 1, okay, so condition 1, and this is the mean for condition 2. Right, so the mean of these scores versus the mean of these scores. Now you can certainly see they're identical. So for sure, the t is not going to be significant. So here's an example where we have R significant, t is not. Okay. What about if we look at this scenario? So again, let's start by looking at the scores of x and y and plot them. So when x is 1, y is 10. When x is 2, y is 20, etc. All right. And again, we would get a perfect relationship that's positive. So R is +1, which means we're certainly going to find R is significant. What if we were to calculate the mean of, level 1 and the mean of level 2? We'd get 2.5 versus 25, which would probably, not saying for sure, I didn't actually do it, but probably we would find t is significant. This is a significant difference between our two levels, all right, between our two means. All right, so here's a condition where both of them are significant. And then this one down here, if we plot the XY pairs, we would get this. And our best fitting line we wouldn't be able to tell if it should go this way and be positive or this way and be negative. We would get a flat line here between them. And you'll learn today that if you get that flat line, it means there's no relationship. So if you were to actually calculate the R value here, you'd get R equals 0, which would give you a non-significant result. If we go ahead and calculate the mean for X and the mean for Y, we would see that they are identical. So this particular case, T would also be not significant. All right. And then this last example, you would get an R value that is not significant, and that's illustrated here. And by comparing the means, you would see that T is probably significant. So you see how, if we look at these patterns, we can see that it's possible to get a significant relationship, and it doesn't tell you whether your means are going to be significantly different or not. Similarly, you might not find a significant relationship, and that doesn't tell you whether your means will be significantly different or not. So, in other words, asking a question about relationships is completely independent of the question about whether the means are different or not. Those are two separate, completely independent questions where you can get very different answers. Okay?